Hello, everyone, and welcome to another edition of Business Calculus. We're doing Math 1325, Section 10.7, Elasticity of Demand. And yes, I do have Wikipedia up. Yes! That's your homework, is to go read Wikipedia of elasticity. So, just between you and me, I'm a math guy. I can do your math. I'm here to do your math. You tell me what math to do, I'll do it, okay? And I get the concepts generally, but you guys are the business folks, so this is what we're going to talk about right there. And I don't know about that guy. And a little bit of this. This is awesome too, I guess. And yeah, there you go. Oh wow, and there's all kind of stuff here. Read this. Go and read this kind of thing. It's super fun, right? And let me just tell you how to get the homework done. So we got E of P is equal to negative P times F prime at P divided by F of P. And you could be thinking, oh, yeah. And hold on. X is equal to F of P. Just in case you were wondering. What is this? So I'm doing the formula from the book, okay? But this is kind of what's going on. Kind of. I mean, I think it's this thing. It's close. So let me tell you how this is going to work, okay? So if you get your E, like this is your answer, by the way. I'm saying like this thing. If you get your E between 0 and 1, then it's called inelastic. If you get your E equal to 1, it's called unit. And then if you have your E is greater than 1, I should put a 1 there. Okay, that's fine. Then it's called elastic. Okay, and they're going to ask questions about this on the homework. What they mean is this kind of thing here, okay? So one side changes more, one side changes less, that kind of thing, okay? So that's for you to go and do more research. I'm going to show you how to do some homework problems and get through this section, okay? So this is not the only formula that they'll use, but it's very related because the other formula is essentially like this part, which I'm going to show you now, like on the first problem. So we got 10, 7, 17. And they have f of x is equal to 146 minus 2x. They say x is equal to 18, and they want the rate of change. And what they mean by that is the f prime over f. So I need to find my derivative, and I put it on top, and I put my original at the bottom, and we're done, essentially. We'll plug in the 18 if we have to. And so this component of it is right here, and so all we're doing is saying, hey, if I multiply it by a number and make it negative, I'll determine what's going on here. So it's a rate of change proportional to the P price, I guess. I think it's price for P. So we're just doing rates of change and stuff, okay? So let's figure this out. I have my f prime. It's very easy. I'm going to just take the derivative as negative 2. And so there's nothing to plug in. I would normally want to plug in the 18 at this point. Like on other problems, that's what I'll do. Actually, not very many problems, honestly, because the next one, you don't do it either. But you would plug in the 18 right here if you could. I just can't, so there's nothing to be done there. F prime divided by my regular f, come on, there we go, is equal to negative 2, and then I got the 146 minus 2 times x. Well, x again is 18, so I can plug it in right there. And so I do the math, and you want me to pull up some Desmos on this. Okay, there we go. So, negative 2 divided by 146 minus 2 times 18. And they don't want the fraction, honestly. I wrote the fraction down, and apparently they did not want that. So, here they go. This is what they want. Is they want the decimal, and that's not hard at all. Not hard. Let's do another one. It's very similar. It's almost too similar, honestly. Like, I should not be doing two of the exact same type of problems, but Sometimes there's no helping it. So what's the rate of change? Same thing as last time. So my f prime would be a 45 right there. And I just divide them, I guess. So f prime divided by f, 45 divided by 183 plus 45 times 3. You can see I need to plug that 3 in right there. No, I want it inside. There. And yes, they do want the decimal. So my answer would be 14.15%. It's not a percent actually at this point. It's like a percentage. So to make it into an actual percentage, you have to shift the decimal over by 2. So you just do 1, 2, and then now you have your actual true decimal that they're wanting. So there you go. Okay, cool. So now let's get back to that crazy formula thing that I gave you at the very beginning. So x, which is apparently equal to f of p, is, I think that's 20,000 minus 175p. And they say find E, and is it elastic, inelastic, that kind of thing. I don't think they care about that elasticity stuff yet. Sometimes they like ask for it, but there's nothing here. So, okay. So what do? The formula, again, is E is equal to negative P times F prime over F. Again, it's that same rate of change. Multiplying it by P, that's all it is. It's not a big deal. So I need an F prime. My derivative would be the negative 175. Again, there's nothing to plug in. That's just what it is. So negative P times a negative 175. Did I say 125? I meant 175. And then I don't know what I said. Do you know what I said? So, 2 negatives make a positive. And like, we're done. There's nothing else. That's what they want. That's what they want in my math lab, is just with the P's and stuff. If they gave us a P to plug in, then I could tell you elasticity, and that's actually the next question is what they're asking for here. So, x is equal to f of p yet again. 12000 minus 10p squared. P is equal to 21. And it's saying, is it elastic, inelastic? I'm going to go elastic, inelastic, or unit. They're going back to what I had said way earlier, right here. Okay, so is it falling into this criteria here, or is it here? And you're just going to multiple choice it. You're just going to multiple choice it. You're just going to multiple choice it. Head nod slowly. You understanding? So, f prime, here we go. I got negative 20p. Because, again, take the 2 down. This guy goes to 0. So I got a negative p times f prime over f. And that's my E. So I got a negative p times, I got negative 20p, and then all over this big number, minus 10p squared. So in the top I got 2 negatives, make a positive. I also got 2 p's to make a p squared. Sweet. And they say that p is equal to 21. So I plug it in. Actually, you know what? I'm going to do it here in Desmos. So p is equal to 21. And then I'm going to say I got 20p squared. 12000 minus 10p squared. And you can do that in Desmos. So that's pretty cool. It makes it really fast. I got 1.162, which is greater than 1. Greater than 1. So if you go back up to that chart, right here, greater than 1, elastic. So your answer is elastic. You're just going to click elastic. Okay. Again, that just means the rate of this is higher than the rate of that. And yeah, not too big of a deal. Again, I'm just doing the math here with you guys. You can read the Wikipedia for yourself. Is this another one? Did I just do this? I did not just do this. This one's a long problem. So, yeah, there are long problems if you have not discovered yet. I certainly have. So it says, when is this thing elastic? And they just kind of leave you hanging. Notice they don't have a p-value, so we have to go and find that kind of. Okay, so derivative, we always do the derivative anyway, so there you go. So negative p f prime over f. That's my elasticity. Plugging that in, plugging this in. So there's my formula again. Two negatives make a positive to make it a little bit nicer. Okay. So this is my E. And they're wanting to know where it's elastic and all that kind of stuff. So what we're going to do is we're going to set this equal to 1 because that's kind of like where the cutoff lines are. I think you can also set this equal to 0 to see the other one. Now, I'm going to have to show you something else that's a little annoying here in a second, okay? But just hang out tight for a second, okay? The reason why I'm choosing 1 and kind of 0 is because 0 is used here, but I'll show you that that's kind of like a trivial case here in a second. But 1 is used for all of these. So I'm either greater than 1, I'm less than 1, or I'm equal to 1. It's all about 1. And so if I set it equal to 1, I could do math with this to go and find out, like solve for p in a way. That's going to be my goal. But first, I do want to set this whole thing equal to 0 for just a second and show you that whenever you have it equal to 0, it means the top is equal to 0. So this here is equal to 0, divided by 40 on both sides, blah, 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 p equals 0. So like that's a trivial solution, but it is part of the answer that we're going to use here in just a second, okay? So the next side is the actual math, where I'm going to set this equal to 1, like I said just a second ago. Set it equal to 1 to kind of just see where that differentiation, well, I guess that sounds like a derivative, the difference between one side or the other happens kind of thing. So moving this over, I got 40p. That's a p right there. I'm going to move this over, and they do not cancel. They combine because you're adding 40 to both sides. 40 plus 40 is 80. Divide by the 80. That's why I have Desmos up. So P is equal to 4.5. This is another one of the answers. So like we got 0, we got 4.5, and we have to find out where this other thing is going to be, okay? And I don't quite know where that is. So big star, when you get this wrong, not if, but when, they're going to say that R prime is equal to f of p times 1 minus e of p, technically, okay? And they say set this equal to 0 and solve. This is a little annoying because this is telling you the other side to where the answers are going to be. I'm just rewriting it right quick. Hold on. There. This one we already solved. Blah, blah, blah. Set it equal to 1. We already got the 4.5 there. It's not a big deal. This one here, you have to move this over. Again, you have to know how factors work. A factor is set equal to 0, so you just set the whole thing equal to 0, and you start solving for it. Divide on both sides. And I got a 9 out of that. Here, I'll prove it to you, okay? So that's a 6. That's a 360. I know that looks terrible. I'm sorry. It's supposed to be a 6. I need my 6s to look more 6-y. I find it amusing. I'm sorry. I've told the joke a few times. You probably heard it in other videos. What? You don't watch my other videos? Ah. So I have this 9, and I just got to say, yeah, I guess that it's cool. I'm looking to see when my original function would be equal to 0, and that makes sense, right? But it's all of these extra components that they're just not quite telling you. So what is my answer, Chad? Yeah, I know. Let's talk about what they're wanting, okay? So they say, when is this thing elastic? And they say, when is this thing inelastic? So they want to know the answers here, and I'm going to give you the answers, and I'll describe it just a little bit, okay? So these are what they want you to type. It's an interval, so that's why they keep it in parentheses, because it's an interval. In order to get these, what we have to do is plug in a value, like a test value between these, to test to see what the elasticity there truly is. Okay, so just give me a second again. What we have for my elasticity is this thing here. Okay, what I want to do is plug in values into this that are somewhere in these two answers, and I'm going to prove my point, okay? So I want to clear these things out because it's like brand new stuff, okay? I got 40p and I got the 360 minus 40p. Now, these are my two my two intervals. You see, my answers were 9, 4.5, and 0. And we're talking like a number line, you know? 0, 9, 4.5 just so happens to be in the middle. And so which side is going to be elastic and inelastic and all this stuff? So we're going to test numbers in between there. I don't know, 1. Just is what's a number between there is 1. Here's another number is 8. I don't like 8. I want 7. Oh, it doesn't matter. You can choose 5. But I'm going to say p equals 1. And what we're getting here is something that's less than 1. So this is less than 1, which means that's the inelastic, if you go back up to the top. Now, if I plugged in an A7 or an 8 or something, I'm getting something that's greater than 1. And that's that elastic, okay? So this chunk here is the elastic, and this chunk here is the inelastic. This is why I do these problems with you, okay? Because who the heck would know what to do here, you know? I mean, come on. So I know that's kind of weird. You know what the math would look like. Just do the math. Just do the math, okay? And just to keep you happy, okay? Just to keep you kind of posted here. I only have 2 questions left. I can't promise that they're great, but I can say that we only have 2 questions left. So we have a formula. Oh, like this is actually a real formula. So R of P, so this is that like that revenue kind of stuff, is X times P. So price times the amount of units that you sell and all that stuff is equal to P times F of P. And so this is actually X. They had said that earlier. Okay. So X, and then we got F of P, whatever, is equal to 63 minus 7 square root of P. Okay, so they say, hey, find R of P. Okay, so you got this. So you got P times F of P is this thingy. Yay, you're done. I mean, literally, we're done. Now, there is a part B, I guess. They're saying what sections of this graph are elastic and inelastic and all that kind of stuff. So they have this kind of, there's sound effects for you. And there's an A that's going up, and then there's a B that's going down. And they're saying A, is it elastic or inelastic? And we got B, is it elastic, inelastic, and all that kind of stuff. So remember, we were talking about this being a rate. So is the rate going up or going down, essentially, that kind of thing? I'm just going to give you the answers. This is inelastic. This is elastic. That's what you put for these answers, okay? We're just getting the job done, guys. We're just getting the job done. So 10.7.79. We got P is equal to G of X, just in case you didn't know, okay? Now it's equal to G of X. We got 9,000 minus 0.1x squared. And oh man, I love when they do this. This is fun. So now they're giving you a new value, a new formula where it's negative g x times g prime of x. Now this is very similar to what we've already seen. It's just kind of like flipped. So it's like the flip version. And it's saying find where things are elastic when this e is greater than 1. Okay. I guess. I don't know. It's like flipped on you. So it's not a hard problem. I do these because they're confusing, though. So g, we got a g prime. So take the 2, you bring it down. This thing goes to 0, so that's easy enough. 2 times 0.1 is 0.2, so there you go there. I got my g prime. And so my e formula in this case is now going to be a negative of the original 9,000 minus the 0.1x squared, and then divided by x times, and then that negative 0.2x. Cool. So they're wanting to know when is this greater than or equal to 1. So we actually need to set it equal to 1 and then kind of just figure this thing out, okay? So we need to solve for it. And that's fine. We can do this. Hopefully. So this down here, first off, let me distribute. And in the bottom, it's not distributing. It's kind of like just mushing them together to be this. I'm going to take this and move it over. So now I got no more fractions. I mean, there's something that's nice. Still negative over here because I'm multiplying it. I'm not changing its sign. Notice that these are like the same thing almost. So what I'm going to do is I'm going to move this over and move this over. What you get is 1 plus 2 equals 3x squared. And then you get 9,000. That's now positive on the other side. Divide by the 0.3, which that's Desmos. And I got 30,000. Now, recall that's x squared. So to solve for x, we need to square root both sides. So my quick and dirty answer is this. Let me show you what my math lab has, and then we'll talk about it. They have this. That's the my math lab answer. Okay. Why? Because technically you can say that this is, I think it's 10,000 times 3, and the square root of 10,000 is a 10 on the out, or no, it's a 100 on the outside. Basically, like you have a pair of zeros and a pair of zeros, so you get a pair of zeros on the outside. That's basically what's going on. So this is their answer again here, but that's an interval, okay? Remember, that's not x and y. That's 0 all the way until 100 and square root 3. So all of this zone is the elastic zone. So where does 0 come from, right? If you go around and look around, I don't know. I guess if I set this equal to 0, I don't think I'd get that same thing. The bottom, you can set your derivative equals 0. I don't know. That's what they got. That's what you do. You put a 0 there. So, I mean, it makes sense. You're starting at 0 for your units, right? So units from 0 units all the way up until this place. Yeah, there you go. Good enough. All right, that's actually all I've got. Thank you. And have a nice day.